Hello everyone and welcome to another Maths tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Permutations and Combinations, long question, example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, in this video, I'm going to discuss two questions which involves the multiplication principle. Okay, this multiplication principle is a fundamental that you should really know before you proceed to learn about permutations and combinations. So now we are going to solve two questions involving the multiplication principle concept. Okay, let me read the first question. In a computer game known as Maze of Tunnels, there are 3 tunnels leading from point A to point B and 5 tunnels leading from point B to point C. Calculate the number of routes a rat can take to move from point A to point C via point B. So this is the first question. Okay, let me read the second question now. Team A, which consists of 4 players, wishes to have a table tennis matches with Team B, which consists of 6 players. Calculate the number of singles matches that can be held. Okay, so this is the question 2. Okay, so I hope that you will attempt these questions in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries, I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve these two questions. Let us begin our discussion for the question 1 first. Okay, so by the way, to solve the question 1, I've already draw a diagram for you. So let me show you the diagram now. Okay, so as you can see here, this is the tunnel diagram that been mentioned out by the question. So since in the computer game known as the maze of tunnels, okay, there are 3 tunnels connected from point A to point B and then 5 tunnels leading from point B to point C. So what I do is I decided to draw in the node diagram. Okay, so as you can see here, A is the first node, B is the second node and C is the third node. Okay, so to differentiate the different routes, so the first route consists of 3 tunnels, which consists of the green color, and then the second route, which consists of 5 tunnels. So that's why I draw in the black color. So from here, you need to calculate the number of routes a rat can move from point A to point C. So from here, from point A, the rat need to move to point C, which is via point B over here. So from here, number of routes will be equals to, so in order to calculate the number of routes, so you need to know the number of routes from point A to point B. So from here we know is 3, and then from point B to point C. So from point B to point C, so here you have 5. So 3 you multiply with 5 over here. So number of routes will be equals to 3 you times with 5. So from here you should get your answer is 15. So the rat can actually move in 15 possible routes from point A to point C. So this is the explanation behind this question 1, guys. Okay, let me underline the solution for the question 1. Okay, so from here you should know that why you get 15. So basically I'm telling you the example. So for example, the rat can move from here to here, and then within this point it can move 5 possible directions. Similar, the rat can move straight and then it can choose the 5 possible direction. Okay, and then the rat can move in right hand side direction, and within here it can move in another 5 possible direction. So that is how it can form 15 possible routes, guys. Okay, so I hope you understand the concept. Okay, let us proceed our discussion for the question part 2. Okay, for the question part 2, similar, I've already draw a diagram. So let me show you the diagram now. So this is the diagram I've drawn for you. So to differentiate the team A and team B, okay, similar concept as the question 1. Okay, since team A consists of 4 players, so I write in the diagram form, which is A1, A2, A3, A4. So this stands for team A. Okay, and then team B, you have 6 players, so I write them in terms of numbers, which is B1, B2, B3, B4, B5 and B6. So it will be easier for us to see them. Okay, So from here, we need to calculate the number of single matches that can be held. So from here, since team A and team B, they are deciding to play a table tennis, so we need to form the matches between team A and team B. So how many possible single matches that we can form? So from here, okay, we know that team A you have is 4 players and team B you have is 6 players. So from here, number of single matches, okay, singles matches will be equals to 4 you times with 6. So 4 times with 6, so from here you get your answer is 24, guys. 24 singles matches, okay, 24 singles matches. Okay, let me underline the solution. Okay, whereas for here I just write here routes just in case, guys. So 15 routes. Okay, just wait. Okay, so for example, within your team A, okay, let me pick player A1. Okay, this A1 can play with B1, B2, B3, B4, B5 and B6. Okay, and then continue with A2. So this player A2, he can play with B1, B2, B3, B4, B5, B6. Okay, and then continue with A3, B1, B2, B3, B4, B5, B6, and then similar to the A4. Okay, so it is actually following in this similar pattern. So that's why you have the numbers of singles matches is equals to 4 times 6. So that's why you have here 24 singles matches that you can possible form. Okay, so I hope you understand the full working that I've shown to you for this question. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks or questions, please feel free to put down in the comment section, guys. Thank you everyone for your support, and I will see you in the next video.